guys to get the full 15 minutes because you need to see that when you slow down, when you get to a question that's not obvious what you're supposed to do, you need to see that you have some time to think about it, try something, see where it goes. There's time to investigate on here. Okay, but part A should be pretty straightforward as far as what to do. So it wants you to find the derivative because there's y's in there. That would be implicit. So I am going to ask and kind of see how y'all did and what your thoughts were with B and C. But part A, for this derivative, you need to make sure that you did product rule. This is x times y squared. So the derivative of x with y squared left alone plus x left alone times the derivative of y squared, which would be 2y y prime. So that would be the first thing I'd be concerned about. Over here, this is x cubed times y, so this is also product rule. So the derivative of x cubed with y left alone, and then the derivative of y with x cubed left alone. You guys okay with that? I would say probably the easiest mistake to make is this, if you couldn't get your answers to work out. This was supposed to be minus this, so when you take the derivative, it's still minus the whole thing. It's not just minus the first term, it's minus the whole purple part. And the derivative of 6 is 0. Sometimes people forget to do the derivative that side. Okay, everybody okay with that step? Okay, so the scoring is usually pretty consistent. I feel like we've talked about a couple of these, but if you have these two y primes where they're supposed to be, you can give yourself a point, 1 point for doing implicit. And for the second point, you actually need to show your work until you get to that. Of course, if you're just pretending like it gets to that and you just kind of fudge some of your work, then you wouldn't get the second point. But you probably need to distribute this. Anything without a y prime probably needs to go to the other side. So I could maybe add this one over, subtract this one over. And even though this is not the most common algebraic solving, it's very common for implicit. If both of these have a y prime, you can factor it out and then undo times with divide. As long as your work shows how you got to that without you skipping steps, you can give yourself a second point. So I'd say there's 50% chance that part of your FRQ on your test will be implicit, but you should also expect a couple multiple choice questions at the very least. I'd say if it's an FRQ like this, you guys should be pretty happy about that because we're telling you what the answer is. But okay, any questions about part A? Did everybody get both of those points? If you struggled getting this, then you definitely need to practice implicit more. Okay, part B. This is the part where you probably had to reread this. You probably didn't know what to do right away, but hopefully you only spent a couple minutes on this and you had a lot of time to do B and C. Okay, B says find all the points on the curve whose x-coordinate is 1 and write an equation for the tangent line at each of these points. So that first statement, find all of the points on the curve where the x-coordinate is 1. What do you think that meant that you should do?
Plug x into the original function. Plug 1 into x.
Okay, plug x equals 1 into the original equation. So when you do that, you end up with y squared minus y equals 6. And of course, FRQs are all about showing your work, so even if you could do that in your head, if you didn't write it down, it's Can't give you points for what you didn't write down. But if you have this somewhere on your paper, that's worth a point. If you have the -6 over, that's fine too. But if you have something equivalent to this, basically, if you plugged in 1 for x at some point, you get 1 of the points here. Okay, how do we solve this?
Factor.
Okay, you could do factoring. So you got y could be 3 or y could be -2. You got that far? Okay, well, if you did that, that was worth another point. Okay, but there are 2 more points in part B for this one. This question wanted us to say when x is 1, write an equation of a tangent line. So how do we normally do tangent lines? What's an equation of a tangent line usually look like? Okay, so let's try to do point slope from this and from this. Equation of a tangent line. It looks like for both of these we know what y is, so we can go ahead and plug that in. I'll be honest with you, I was reworking this one during advisory today, and I struggled, or I spent a lot of my time thinking about what x has to be. How could I figure out what x is? Right, so I was trying to plug y equals 3 into the original equation and solve for x, which should work, but without a calculator, I was pretty much stuck. Then I reread part B, and it says when the x coordinates are 1. So this was like 1, 3, and when I plugged in 1 for x, I got -2. So I technically also knew when x was 1, when x is 1, but that wasn't obvious to me. I had to go back and reread to catch that. The last 2 points on this come from finding the slope. How am I supposed to know the slope? Okay, the derivative at that point. So you needed somewhere to say y prime at 1, 3. I'm looking at the derivative, so even if you struggled with part A, they're telling you what it is, so you should still be able to recover in part B. If I plug in 1 for x, 3 for y, 3 for y, 1 for x, 3 for y, and 1 for x. We end up with 9 minus 9 over 6 minus 1, which ends up being 0. So the slope at that time is 0. Slope comes from the derivative. So this was enough to get the third point. If you want to just say y minus 3 equals 0, that's fine. If you want to say y equals 3, that's fine. Anything that's equivalent to that is worth a point. Over here, for you to find the slope when x is 1 and y is -2, if you ever need a point, you plug it into the original equation, the original function. If you need a slope, you plug it into the derivative. So if you plug this one in, just for time purposes, I'm going to go a little bit quicker here. I got that, which simplified to be +2. Okay, did anybody get that one? A few? Okay, that is worth another point. So there's up to the 6 possibilities. Now again, it is very, very, very common for people not to get all 9 points. The intent here is for y'all to see where you were at and try to find a couple of points that are reasonable to get next time. So I certainly expect some of you guys did not get these 2, but you need to learn from your hiccup. If it was not thinking plugging in 1 for x based on those directions, you could see that why that helped. Knowing the y values, how that helped you come up with these equations, where the slopes are supposed to come from, all of that kind of stuff. So anything specific about part B in his 4 points?
I have like a minor question.
Okay.
So hypothetically, if you were to get like all the points on this FRQ, would that be a good indicator that like we're prepared for the test?
Not necessarily, because the test, as I said, I'm not doing this FRQ because your test FRQ is going to be the same. But it should be on par with the same level of difficulty. So I would feel, if you got all 9 points on this, you should feel very good about yourself. I don't know the exact average of this, but usually FRQs average between 3 to 5 points.
Okay.
And that's why I started off with the curve, because when y'all take your test, if you think the FRQ is hard, like this one to me is pretty tough, if you just give up and you just get a point or two and you're not using your time, then your grade might end up around a 75, even if you do great on the multiple choice. But with even 15, we give you more than 15 minutes. But as we get closer to the AP exam and we try to get you used to the 15 minutes, there's a big difference between getting 2 out of 9 and 5 out of 9. So y'all just have to get used to persevering and not giving up when you don't know instantly what to do. Any other questions about Part B though? Okay, then Part C. Find the x-coordinate of each point on the curve where the tangent line is vertical. So, when you read that, what do you think that means we should do?
I have no idea.
What do you try?
Doesn't it mean like that the bottom part, like the 2x minus x cubed has to equal 0? Because the slope has to be like undefined, it's vertical.
Uh-huh. So you got to think about it like this. If the tangent line is vertical, what kind of slope does a vertical line have? Okay. How do you get an undefined slope? When you try to divide by 0. So if the slope is the derivative and you want to know when it's division by 0, you should have set the denominator of the derivative equal to 0. And if you did that, and you didn't just keep it in your head, that's worth a point. Vertical lines are undefined slope. Slope is like derivative. A derivative is going to be, or slope is going to be undefined when you try to divide by 0. So that was point number 7. And then for the other 2 points, we needed to try to solve this for x. So anybody have an idea of how we might solve this? Okay, good. You could try to factor out an x. And again, that may not jump out at you, but if you don't quit on the question, you might consider that. And then why is x times 2x minus x squared equal to 0? Why is this maybe helpful? Right. So similar to when you did this in algebra class, if this times this equals 0, either this could equal 0 or that could equal 0. So same idea here, it's just messier looking. So if we said, well, when x equals 0 is one case where you have a vertical tangent line, we could go to the original equation, plug in 0 for x, and you end up with 0 equals 6. And since that is not a true statement, that just means x equals 0 never occurs on that graph. 0 just doesn't exist. So if it doesn't exist, it doesn't have a vertical tangent line. And then for this one, you could try to solve him for y by adding this over and dividing by 2. Okay, and then here's where the next to last point comes from. If you know what y is in terms of x, you could take the original equation And everywhere there's a y, you could substitute in this. And if you even make that substitution, you get the 8th point. Again, not obvious. No one's pushing you in that direction. There's no helpful reminders. It all boils down to when you have the time, looking at it, having some stuff to try. If it doesn't help, you erase and start over. But if it does help, you keep running with it. So when I look at this, x times x to the 4th times a 4th would be 1/4 x to the 5th. Over here, x squared times x to the 3rd times a half would be 1/2 x to the 5th. These are both x's to the 5ths. 1/4 minus a half would be minus a 4th. Multiply both sides by 4, divide both sides by -1. And then how do you get rid of a 5th power? 5th root it. And that was the last point. You need to get all the way down to what x equals. 5th root of -24. Now, one thing that sometimes people ask is, I thought you can't take a root of a negative number. Were y'all the class that asked about that a couple weeks ago? You can't take the square root of a negative, or a 4th root, or a 6th root. You can't take an even number, because if anything times itself an even number of times is always going to be positive. But an odd one, like a cube root, could be negative. A 5th root could be negative. So that's perfectly fine. So that last point was pretty tough to get. Again, there's some steps in there that are not intuitive, but they do sometimes show up on FRQs, so it's still good for you to learn from. So what I think you should do, again, if I take this up for a grade, it will just be participation grade. I'm not going to penalize you based on how you did. But you should really count up your 9 points right at the top, how many out of 9 you got. And to get something out of this process, whatever score you got, you need to think about what would have been the next easiest 1 or 2 points to get. If you got one similar to this in the future, not our test, but how could you have squeezed out an extra point or 2? Okay, I'm done with this one unless you guys have more questions. Did anybody get all 9?
After I copied all your work.
That's my points. How about 8? Anybody get 8 points? 7? 7's still really good. I'd be very happy with 7. If you make a 7 on all of your FRQs on the AP exam, I'd say it's going to be really, really, really hard to fail the AP exam. But 7 is pretty tough to get, so don't get overconfident either, though. Just because you got 7 on that one doesn't necessarily mean you'll do so well on ours. Okay, let's see what's next. Okay, so you guys have your test next class. So one of the best things, that's the single most important document, not the only important document, but the single most important document is the test review. You guys should be finished with that, or minus 1 or 2 questions maybe, because you had the Friday class to work on that. That is one of the things I'll be asking you to turn in the Google Classroom. So if you're finished with it, you can go ahead and turn it in. But you should probably use some of your class time to kind of look back at those questions, look at the questions you missed, think about the things you didn't know. Maybe even try some of those a second time. But you need to feel very good about the test review if you want to feel very good about the test. Also, I need some stuff turned into Google Classroom, so that would be the test review for sure. And I also opened up number 47 if you choose to do it. So let me speak on that real quick, because some of you might move on to that soon. 47 is the related rate circuit that you guys picked up on the way in today. It's 2 pages. At this point in the year, it is optional, so I will not assign you a 0 if you don't do it. And honestly, I was kind of debating on even giving it to you because I'd kind of like to give it to you in like March as a good refresher. But if you do at least half of it and turn it into Google Classroom, I'll give you the homework grade. So there's that incentive, and of course more practice on related rates should help you feel more confident about the test, since that's one of our two big topics in this unit. But it is optional. If you do at least half of it, I will give you a 10-point homework grade. And you should keep it, because in the second semester I will probably require you to do the whole thing. So those of you that do at least half of it before our test, you'll have a head start, or even better if you do the whole thing. So I'm trying to be flexible there. If you know you need more practice on related rates, or you don't know what else to study, then that way you're getting some points for it, even though you don't have to do it right now. Okay, and then last thing, and then I can come around and help a bit, but late work policy reminder. So just like the first two units, all the way throughout the whole year, but I do not take any late work from Unit 3 once we start the Unit 3 assessment. So if there was anything in Unit 3 that was due, and you got a 0 on because you didn't turn it in, you can still do it, turn it into Google Classroom, or give me the hard copy before we start the test on Wednesday. And you can get half of the points back. Or if there was anything that you did incomplete and got half credit on, if you finish it and turn it back in before the test, you can get half of those points back. So if that applies to you, you need to add that to your to-do list, because I will not accept it after the test. So those are the things to be working on. If you think your time is best spent looking over the test review, studying those, practicing those, looking at your mistakes, whatever, then do that. If related rates you know you need more practice on, go ahead and start on 47. And I will try to give you that flexibility. And I will make some circles here to see if I have anything I can help y'all with. I don't have the related rates circuit finished, but I will try to do some of it between questions.
Would we expect this on this without a calculator?
If you look at the answer, that usually is kind of a hint. Yeah, you're not going to come up with that by hand, so that would be a calculator at the end. Grace, what do you need?
I just wanted to read in the Unit 3 review, test review.
Okay. Do you know where I put the extra copies at?
I looked through it and it's number like, I don't know.
If you know the number, there should be some in there.
In case you weren't there, we beat them.
Tristan, no.
22 to 21.
On task.
I'm thinking.
No. Keep it to yourself.
I might need to share with you because I'm a little upset.
Okay, I can help you.
So I'm trying to like working backwards, but I'm also, of course, trying to work forward.
Okay.
But I don't know how to do this part of it.
You've got some divided by constant, but one here.
Oh, crap.
Derivative of the top at the bottom left one minus derivative of the bottom at the top left one, all over the down here. I will also remind you on the test review, I did try to put some quick bit.ly links on there. So if you know you need more practice on implicit, I think that bit.ly link takes you to the Khan Academy implicit type questions. And of course you can just practice those until you feel better about them. Same with the FRQ, there's some extra practice links. Related rates, I think there might be a few extra practice links.
So which one, the, this equation, the trace
I like
price.
zero out.
Lose revenue. We're doing it in relation to the height, so
I just did it.
if we find the derivative on page, we have to add it to line, right?
You're doing this with respect to time. You're taking the derivative with respect to time, or is a function of time, you're taking it with respect to yes. B is not the same thing as D. When you take the derivative of B, you need to
So,
and you take the derivative of H, you need to do.
H would be that, right?
You already know the derivative is supposed to be around -0.4.
Where should B prime? I don't see that in your
Probably just some of
I
them
don't know,
are
since we were doing it in relation to base, that it wouldn't be.
probably some of them like are imaginary numbers.
No, it will be there unless you're taking it with derivative with respect to B, which I don't know why that would be. Related rates are always with respect to time. Are always a function, so you need a B prime.
Well, then this would just be zero.
2 times a half is not 0. That would be 1.
I don't know.
Just so you know, on this too, here, there's a lot easier way to do that. You know how to use your score better?
No.
You see how you wanted, it looked like maybe X was 5 before. If you had to be 5 before, like this button, for score, sort it into like X. And then, when you're typing out your thing, you can just do like a cosine, you see your X. To X. You know, then you don't have to type in 5 before, you make it all the
It's 0.5. Yeah. Just set it in practice on that.
I've had a few questions about number 2 on the circuit, but I have not had time to work it, so give me a second and then I'll come back around. But again, your priority should be test review first. If you feel good with all the test review, you can do some extra practice on those links or the circuit. Number 2 on the circuit, did y'all end up with 3 centimeters per minute? Yes? Okay.
I always thought that you have like 2, but you have 3 zeros.
Not necessarily.
Yeah.
How many times does x cubed equal 0?
Is that the right form?
Just the ones, right?
Yeah.
It could be up to 3. A circle, let me work it out. just skip it for just a second. Like I said, I've not worked, I don't know if I've ever done this circuit. So I will have to have a minute to try the questions before I can help. For the circuit, you certainly do need a calculator on these because they round all the answers. I'm with you to here, but I got a different answer. So, type that back to your calculator. Wait, you got it right there. Okay, you can put it in radians. That's only going to really matter though if you're doing a trig function like sine, cosine function. That's how you did this. So your calculator is always going to do order of operations very strictly. So it's doing this division and then coming back and multiplying that. That's not what you mean. See? You're still getting the same answer. What you mean is 32.5 divided by that whole thing. So you need to either put it in parentheses or do it over 2 steps. So divide by, and then do parentheses 10 pi. Oh, okay, yeah, that's fine. So now you just divided by pi. But because in an order of operations, it does multiplication and division at the same time, it's doing the divide by 10 and then multiplying by pi, but you need to divide by pi. And now you match it. So typically, anytime you put a fraction in your calculator, parentheses are on the numerator, parentheses are on your denominator. Be safe. Did y'all have something from the test review I could help with, or I have to finish anything else?
Thanks. Any questions, maybe just watch the videos.
Did y'all have anything from the test review that I could help with? Or on other stuff? Y'all didn't have a test review? Why not? But did you get any else understanding?
Which is
Is there anything on the test review that I can post?
like, let's put it in parentheses.
Did you say anything in the grammar when you guys?
I did, but I didn't know it was you
Oh, okay.
until later. I just saw your orange. Okay, y'all have anything for you that I can help with? Okay, if you find something, ask right away.
I've got a question.
No. Do y'all have anything from the
This
test
is
review that I can help with? No?
Actually, you could explain this FRQ, because I was confused about the K. Let's do part D.
Okay. Well, let's see what you got. Write an equation that can be solved to find the actual value of K, so that the point 4.2K is on the curve. Okay, well here's your curve up here. So basically it's saying if you plug in 4.2 everywhere there's an X, and K everywhere there's a Y, you should have a formula that could solve for K. Part D doesn't want you to solve for it, it just says write an equation. Yeah, it says everywhere there's an X, plug a 4.2 in, everywhere there's a Y, plug in a K, and then that's all you have to do for D.
Okay, I might have a better question once I go through it.
Okay, that's fine.
Thank you.
Y'all didn't have anything from the test review? The
I
cleanup?
feel good about it.
Okay, I think I've exhausted the questions from test review. But if you are still looking at that and you see any questions, then please ask right away, because that's the most important. For those of you on the circuit, of course I will help with that as well, but they should start off like most circuits where they start off a little bit easier and then kind of build up in difficulty. So. And there's 12 of those total, so again, if you do at least 6 of them, I'll give you the homework points. But the real purpose is to try to give you a little bit more extra practice. So you're certainly encouraged to work on all of them. I will say one thing about the circuit that I already don't like is the units. You guys should still be trying to make a habit out of putting the units each time. Area units are always squared, volume units are always cubed, length units are always linear. If it's a rate of change, it needs to be per an amount of time. If you don't make a habit out of always doing that, then you may not remember to do it on an FRQ when you need to. So. Okay, we've only had time to do the first three on the circuit, but if you need help with the first three, then let me know. And I'll try to help you.
I know you haven't gotten to mine, but is that how I take the derivative of
No, because here you're going to have to use the product zone.
that?
Because it's r squared times h.
Okay, so then, so this part's correct.
Personally, I would put this number just out front of the parentheses. Don't worry about it later. I would do 1/3 pi parentheses,
That makes sense.
and then I can put the focus on the.
And then do the previous.
So I'll do the r squared h. So the derivative of r squared h would be.
So R plus
Close, but
up
here,
to R prime.
you do the r prime also.
Okay.
And then start plugging in what you have. So it's on there.
Okay, thank you.
So what is this asking me to do? Okay. First derivative, was that correct? Or did you check? I guess I know. Let me see. Let's make sure that part's okay first. Actually, I don't know if I have this worked out, but I can start it up here. It's number 7, you said?
Yeah.
I have a question about the tester.
Okay. What is your question?
For some reason, on one of our answers, all the signs are flipped,
Okay.
but I can't see any error with.
Well, let's say,
Well, not all of them, but like, it should be negative. Wait. It should be y minus 3x squared over 3y squared minus x, but I got
well, you guys.
negative y plus 3x squared over x minus 3y squared.
Okay, I'll help you in a minute, but I didn't catch any of that, so
Okay.
let me finish with him. Okay, is that what you got for first derivative?
Yeah, I just had all this times, it's the same, right? I had, negative 2y minus 7 over 2x minus 3.
Okay, but do you understand that this is equivalent to that? Okay, that might be Grace's issue too, I'm not sure. Okay, and then for second derivative, you're going to have to use quotient rule because you've got something divided by something. So derivative of the top with the bottom left alone minus the derivative of the bottom with the top left alone, all over denominator squared. You okay with that so far? Okay. Now, again, if this was multiple choice, there's probably going to be a bunch of simplifying involved. But technically, this question says in terms of x's and y's. So it's fine that I have x's, it's fine that I have y's. The real problem is this guy. Y and y primes are two different things. So this is keeping me from calling this good enough. So, do you know what we could maybe put in place of this? Right, what you have right here. So if we make that change, so if this was an FRQ, I would encourage you to quit here because this is equivalent to what the answer is. But most of the time it's multiple choice. So to try to get it to look like the answer on the back page, did you notice that these two cancel?
Yeah.
Okay, and that leaves behind a 2 times the 7 plus a 2 times the y. And then a 4 times a 7 and a 4 times a y all over this. And I'm not going to FOIL that out unless I just think that that's going to be helpful. And looking at the answer, I can see one of them has this as a denominator, so that's probably fine. But if we combined our like terms, we've got 30, 42, and 12 y's. And then we could factor out a 4. 4 times 7, 14. 14 would be times 2, 28. Well, okay, hold up. That part looks wrong.
Are you trying to factor 4 out of that numerator?
Yes.
You can factor 2 out, so 2 power 4.
How would you? Wow.
Okay, yeah, so there's a mistake in here somewhere. Because I'm comparing it to the answer. So it's got this. That part's fine. and it also has a 7 plus 2y, what the 4 factored out. That's why I was trying to factor out a 4. But that doesn't look right. It's 8 and 4. Oh, okay, here's my mistake. Right here, I had a negative times a negative 2, and for some reason I called it a plus 4. That should be a plus 2. Which makes this a 14 plus 4y, which makes this a 28 plus 8y, which means I could factor out a 4, and then that works. So just one careless multiplication error can make it seem confusing, but that's also a pretty tough question as far as length. But I'd say obviously being able to take the derivative is good. Knowing that they were asking for the second derivative is good. Knowing that if you want this in terms of x and y's, you can replace y prime with what y prime is equal to. That's pretty important. So, is that enough for that? Yeah. Okay, Grace, can you tell me what your thing was again? A little bit slower so I can actually write it down.
So the problem is take the derivative of x cubed minus x times y plus y cubed equals 1.
What number are you looking at? I have no idea.
It's just the fourth question on the unit review.
Question 4.
But I just wanted you to check my math because
Okay, well, let's just quickly check. I would say after you take the derivative, if you remember to do product rule here.
you're doing the same thing as me. Just like keep going. So.
Okay, I know, but I wanted to make sure that we were on the same page here.
Yeah. Okay.
Because if we were different on step 1, then there's no point in looking at step 6. So, you're okay with that?
And I'm supposed to put y prime after 3y squared, right?
Yes. Yes, yes, yes. Thank you. So you agree with that?
Yeah.
Okay, if I keep the y prime stuff on the left, maybe add this over, maybe subtract this over.
That's what I did, but like the opposite.
Like you did these in the other order?
Right, so I did 3x squared plus, 3x squared minus y on one side. And then on the other side I had x, y prime minus,
Oh, you moved the y prime stuff to the right?
yeah.
Okay, let me do it the same way then. So if you move the y prime stuff over, this guy becomes positive because you have to add him over. This guy becomes negative because you have to subtract him over.
Mm-hmm.
Now we're back on the same page?
Yeah.
Okay, both of these have a y prime, so factor it out. Undo times with divide.
That's what I got, but the answer says not the same.
It's the same thing.
Really?
Yeah, because like you remember when we did complex fractions, like something like this, I wanted to multiply this by 2 so that those would cancel, and so I had to multiply everything by 2, that type of thing. As long as you're willing to multiply every term by the same number, it's really like what you're really doing is multiplying the whole fraction by 1, 2 over 2. It's just that this gets distributed, right? Well, up here, you may not see the need for it, but if I multiply this by negative, that's okay as long as I multiply everything by a negative. So along the same lines. And now, you could put this guy first, he's positive.
But do I need to know to do that in order to get the right answer? Like, would they still count that as the right answer?
On a FRQ, absolutely. But on a multiple choice, if you don't see how to go from here to here and you pick something else, then that's where you would miss out.
Okay, thank you.
It's also, another way to think of it is just kind of like if you factor out a negative out of the numerator, as a GCF. That swaps both the signs.
Mhm.
And if you factor a negative out of this, it swaps both the signs, and then the negatives can cancel and give you the signs you need.
Okay, thank you.
I like the little.
Will you print this first again? Circuit?
Is it not up?
Are you just looking at?
I didn't think. Let me look again. I didn't see.
Or
Oh, just kidding. I didn't. I didn't see.
Again, if y'all do at least half the circuit, you should turn it into Google Classroom, because they'll give you a homework grade for it.
So we don't-
Ideally, do the whole thing so that you have it set.
I'm not quite sure where I'm turning wrong. So the solution or the equation for we're trying to find the radius.
I have it lined up first, but moving here, good. What is the radius in centimeters? So R is what you're trying to find.
Yeah. I know the equation is 4 pi r squared r prime for the derivative of the volume of the sphere. So I plugged in what I knew,
Okay.
but I got this like really wonky number that doesn't match anything.
I guess would be the way you type it in the calculator.
I typed it in like all different kinds of ways.
So let me see what you're.
First of all, I think 25 is negative, so I just left them as positive to make it easier. But first of all, I started off with dividing by all of it, and like,
Okay, but I need to see how you're typing it in. Because I think that's your mistake. Right there, I'm almost certain. Keep going, so I can tell you when you go all the way up.
4,
There's your mistake. Your calculator does order of operations. In order of operations, it does division and multiplication at the same time, left to right. So it's doing 2,500 divided by 4. Then it's multiplying by 5. Then it's multiplying by 25. You really want it to divide by all of that, so you should put that in.
just retype it all.
Anytime you do a fraction in your calculator, you should put parentheses around the numerator and denominator. And that's gonna be better.
Since it's r squared out, so it's considered.
And then make sure that answers something. So you either have to remember one of two things. You either have to do the parentheses to make sure it divides by all that,
Or
or
just do a straight fraction in there.
yeah, you know how to do that?
Yeah.
Because then it does imply parentheses, so that's fine.
That's just
I don't know, I haven't tried this one. Tool, so I'll do that. The radius is twice the height. Okay, so you do the derivative.
Your derivative looks fine, and you had all that information. You didn't have that one. Yeah, so I think even though this is technically the derivative, I think you should use this first. So maybe instead of saying h, say r over 2, and then you can write it in terms of r, and then there won't be an h prime.
Okay, we're down to about 5 minutes till dismissal here. So just a 30-second recap. You've got tests next class. Of course, you should jot that down in your planner. Even if you don't need to study much, 5 or 10 minutes will certainly help. If you have any late or incomplete work, make sure you do that and turn it into Google Classroom or be ready to hand it in. That will be your last chance. If you want to do at least half the circuit, I'll give you homework points for it. Make sure you keep it though, because I'll probably ask you to finish it next semester. So force you to think about these again before the AP exam. And I am asking you to turn the test review in the Google Classroom, so make sure that you look at that sometime between now and Wednesday. And then I guess the only other thing is on this daily meme. Do y'all understand the joke behind that?
Yeah. Yeah. There's no change.
Yeah. You can say you're going to change, but you're still the same person.
You ready? I know it's a video, so you can't put it up there, but it's still funny.
Okay. What am I watching? Yeah. Oh.
I thought
I'm
that
not,
was funny.
I don't know what that movie is. Though.
It's
I don't know if
Megamind? I don't know. Is that a
I don't know if
movie?
animated pictures work.
The what?
I don't know if animated pictures work, but yeah, that's the same type of joke.
Yeah, yeah.
I was surprised that something math related came onto my phone. Still fun.
Also this weekend I had shared something on Google Classroom. University of Arkansas was offering some free application days. Oh, never mind. It's over anyway. Yesterday was the last day.
Any plans this weekend?
It's Monday.